This is the 6th video on trigonometry, where we're going to have a look at solving some simple trigonometric equations. So, here's the first one, nice and simple. I'm told that sine x is equal to a half. Now, we already know one solution to this. We've already seen it several times in these videos. Hopefully you know that sine 30 is a half. It's one of the exact values that we looked at in the very first video. So we know sine 30 is a half. So that's one solution to this. However, we've also seen that when we draw out the sine graph, there are actually other values that would be equal to a half. So here's half. Let's remember that the sine function goes up to 1. So there's this answer here, where sine 30 equals 1/2. But there's also another answer here. And there would also be another answer over here. There'd be another answer over here, and so on. So I can use the symmetry within the graphs to find these other solutions. So for example, if I know that that's 30 degrees away from 0, then I know that this solution here will be 30 degrees away from 180, because I know I have the symmetry of this graph like that. So I know that this solution is 150. And do check down your calculator if you want. Type in sine 150. You will get 0.5. In a similar way, I could work out this solution here, because I know it's going to be 30 degrees above 360. So that would be 390. And I could keep going. But there has to be a limit. There has to be somewhere where I'm going to stop, because otherwise I'm going to go on forever. There's going to be an infinite number of solutions to this equation. So usually you'll be told to find the solutions just in a set range, just between two values. So a question might say, solve this between the values of 0 and 360. That's probably your most common range, because it's one cycle. And in which case, these would be my two solutions, and I wouldn't include anything above that. Okay, this question looks a little bit more complicated, but it's just going to involve a little bit of rearranging so I can get the cos by itself. So I'm going to add the 1 to both sides. So I'll get 3 cos x is equal to 2. I'm going to divide by 3. So I get cos x is equal to 2/3. Okay, now, this is not a nice exact value that I know about. So I'm going to get my calculator out, and I'm going to use the cos inverse button to work out what that angle would be. I need to do the inverse of the cos function. So I'm going to type in cos inverse 2/3. And I get to 1 decimal place, 48.2 degrees. I'm now going to draw the graph, so I need to find the other solution in the range of 0 to 360. So, draw a quick sketch of the cos graph. Like that. I'm trying to find when this is equal to 2/3. So 2/3 is about here. So I know it's equal to 2/3 here and there. I already know what this solution here is. It's the 48.2. And so this solution here, using the symmetry of the graph, if it's 48.2 degrees away from 0, it's going to be 48.2 degrees away from 360. So if I work out 360, take away 48.2, I am going to get my second answer, which is 311.8 degrees. So those are my two solutions to that equation. Next example, this same idea. This is just going to involve a little bit more rearranging. So first thing I'm going to do is I'm going to move. I'll take the 1 away from both sides. So I will have minus 2 over tan x is equal to 3. I'm going to multiply both sides by the tan x. So I'm going to move the tan x to the top over here. And at the same time, I'm also going to divide by the 3 to move the 3 down here. So I'll get that tan x is equal to minus 2/3. This is not an exact value, so I'm going to need to use the inverse tan function here to work out the angle. So I'm going to type into my calculator tan inverse of minus 2/3 and I get minus 33.7 to 1 decimal place. Right, I need to draw my graph. Now, in actual fact here, notice that the answer my calculator has given me is negative. So I need to draw the tan graph, and I need to go past the y-axis a little bit. I'm going to start at minus 90, 180, 360. Draw your asymptotes in. Okay, and I'm looking to see when this is equal to minus 2/3. Minus 2/3, it's roughly about there. So I've got one solution here, I've got another solution here, and my third solution is over there. My calculator has already told me this solution. So, using the symmetry of the graph, right, so I'm comparing this point here to this point here and this point here, because those are the bits on the graph, these are the points on the graph where my tan is always equal to 0. 0 here, here, here. So if it's 33.7 degrees away from 0 here, it's going to be 33.7 degrees away from 180. So I'm going to do 180, take away the 37.3 to work this out. Sorry, the 33.7, and I get 146.3 degrees here. And to get this answer there, again, I know it's got to be 33.7 degrees away from 360. So 360 take away 33.7, and I will get 326.3. So on the graph I have got 3 different solutions. However, looking at my range up here, my answers have got to be between 0 and 360. So this is not in that range. So notice I didn't put a box around that solution, because that's not one of the answers I'm going to give to the question, because it's not in the range. It was really important, and I needed to write it down to help me to work these things out. If I didn't get that in the first place, I wouldn't have been able to get these two solutions. So it's really important, but it's not a final solution. Okay, last example. You can see here, again, I've just got a single trigonometric function. There's just the cos there. I don't have a mixture of functions. So even though it's more complicated than the previous examples, it's still a question similar to them. It just looks more complicated because it's a quadratic. But that's okay, because we know how to deal with quadratics. We know we've dealt with them throughout GCSE, so we know that we need to factorise a quadratic. So that's exactly what I'm going to do. So I've got a 2 cos x and a cos x. I need two so I'm going to have to get a minus 1. So if I have this as my plus 1 and this is my minus 1, I think that should work. So if I was to multiply this out, I get my 2 cos squared x. I've got my plus 2x, my plus 2 cos x minus cos x gives me my plus cos x, so that's okay, and my minus 1 times the 1 gives me the minus 1, so that's okay. I could have gone through a longer process of factorising that, but we spent so long factorising. Hopefully that's pretty clear for you. So now I've got my two brackets equal to 0. I know that either this bracket is 0 or that bracket has to be 0. So either cos x must be equal to a half, because this is going to have to equal a half if this whole thing is going to equal 0, or cos x is going to equal minus 1. Right. I know this one. I know that x will have to equal 60 degrees. I know that cos 60 is a half. It's one of the exact values we know. So we know that one. Let's just draw the graph quickly to work out the other solution that corresponds to this one. So So 60 degrees is here, and so I know that's going to be the same as 60 degrees from here. So 360 take away 60 will be 300. So those are my two solutions that come from here. I've also got some solutions over here as well. So cos x is equal to minus 1. Well, actually, I've already got the cos graph here, and I can see that when x is 180, the graph is minus 1. So x is equal to 180, and actually, that's the only time when when cos is equal to minus 1. There are no other points on this graph where it's equal to minus 1. So 180 is my only solution that comes from here. So my three solutions are 60, 180, or 300. And do a quick check. If we want to make sure we've got this correct, we can substitute these in to my original equation. So if I worked out cos 2 times cos 180 squared, if I typed into my calculator cos 180, then square it, times it by 2, then add on cos 180, and then subtract the 1, you should get 0 as a check. And you can do the same thing with the 60 and the 300 as well.